Hi, today we will be introducing a new technique for integrating AI into forensic investigations. The problem we will be trying to solve using our machine learning technique is identifying and detecting illicit transactions in a blockchain ledger. This could help speed up forensic investigations by assisting in evidence collection and also help us gather information to get a more complete picture of the crimes we are investigating. What are licit and illicit transactions? Illicit transactions include any transaction made using a cryptocurrency that is linked to illegal activities such as scams, terrorist organizations, malware, etc. We could identify whether or not transactions are illicit by looking at information about the transactions and the wallets, such as the time the transactions took place, the transaction fees that were charged, the amount of transactions made to a wallet, etc. The transactions and wallets in a ledger can have many features used to identify illicit activity, which makes it very hard to accurately detect all illicit activities. How will we solve this problem? We need to start by finding the best way to represent a blockchain ledger and its features. Then we can make use of a machine learning technique that can be trained to accurately identify the illicit activity. We will represent our ledger as a graph, where the vertices represent a transaction and the edges represent the flow of money between transactions. We will be using the elliptic dataset that provides a Bitcoin ledger represented as a graph containing 200,000 transactions with 166 features for each transaction. 21% of the transactions have been classified as licit and 2% as illicit, and the rest we will have to classify using our machine learning technique.
Thank you, Hannes. I will now discuss how random forests work. So we decided to use the random forest AI technique to solve this problem. What a random forest is it uses another method of classification called decision trees. Now, decision trees are constructed by making decision nodes in a tree based on certain features of the data. These decision nodes then determine how the tree will classify a data item. The decision tree chooses which features should be used as decision nodes based on which features have the highest entropy with respect to the classifications. A random forest builds multiple decision trees, each trained on only randomly sampled subsets of the data and using only a subset of randomly chosen features. The random forest will then make its prediction based on the most popular prediction made by all its decision trees. By making these random decision trees on different aspects of the data, we prevent having only one decision tree that can easily overfit the training data, making it more accurate on unseen data. This method is very effective on datasets with a high number of features and a large sample size like we have with the publicly available elliptic dataset. So to quickly give you a look of the AI that we wrote, the first thing is we load the data from these 3 CSV files available on the elliptic dataset. We then proceed to process and format the data before visualizing it to be easily able to understand the data itself. So we print it out as a graph. If I run the program in our PyCharm IDE, you will see that the data is first loaded before a graph is printed, as Hannes mentioned earlier. And this graph represents the different transactions that are connected with the different edges. So after this first graph is printed, we print an output of the different classifications of each of the transactions, where the majority of transactions are classified as unknown, and the task is to classify these as either licit or illicit, taking the first 2 columns as training data. So given the information we know, we classify or color code the different transactions, green being licit, red illicit, and orange being unknown. After this stage, after everything has been printed, we prepare the data for classification, and then we proceed to create a random forest using the scikit library. So as you can see, the output on the training data has just been printed to the console with a precision of 99%. What you see here is all the unknown nodes have now been classified into either the illicit or the licit category. And if I close this, we have one final output showing the graph once again with no more unknown nodes, but all licit and illicit, or all nodes assigned to a licit or illicit category. As we can see, we would expect most of the nodes to be licit, but a good portion of them are illicit as well. In conclusion, random forests can be a very useful technique for forensic investigations to detect illicit activity, not only for cryptocurrency transactions, but other areas as well, such as detecting suspicious activity in large log files. We also want to note that these results should still be verified and further investigated by human experts, since AI techniques are not 100% accurate, but they do help accelerate this process significantly. Though most of our code draws inspiration from online solutions, we take credit for approximately 20% of the code mainly including visualizing the data and preparing the data.